Wheatstone bridge, it shows a special type of circuit. It is a special type of circuit arrangement. Okay, it is a special type of circuit arrangement. We can say to derive its equation, its relation. Let us take a simple circuit of Wheatstone bridge. It was told that if we are having combination of 4 to 5 resistors like this, in between them there can be resistors or galvanometer, anything. Okay, let it say R1, it will be R2, R3 and R4. Okay, if it is connected through a battery of a cell of the voltage, let us suppose it is supplying current I. We know if it is, and it is a galvanometer, it reads small current also, that's why we are using galvanometer. Let us suppose a current I is flowing through here. Okay, what will happen here according to Kirchhoff's current law? What will happen here? There will be a current distribution. Okay, one current will go here. Let us suppose I1 will go here, and suppose I2 will move here, and we know I2 will be I minus I1. That's all. Now I1 current flows through here, and now at this point two branches come, but we see that galvanometer reading is always 0 in this type of arrangement. How? Let us suppose we see here that I is equal to 0, that is galvanometer reading is 0. What will happen? I1 current will go through this path, and I2 current will go through this path, I1, I2, and they will join together and form here I. What I am telling that galvanometer reading is, let us suppose 0. Then to have I is equal to 0, what is the condition, what is the relation between the resistance, that only I want to form. Okay, now if we write one KVL equation here and one KVL equation here, let us suppose it is loop 1, it is loop 2. We can say in loop 1 we can say it is minus of, yesterday I have told you, minus of I1 R1. You come here and go here, no resistance. Now here plus R3 into I2 is equal to 0. That means we can say like this, what? I1 R1 by R2, I1 by R3 is equal to what? We can say like that, it is I2 by I1. This, let us say it as equation 1. Similarly, when we write in this equation, KVL in this equation, loop 2, in loop 2 we will get similarly like this, what? Like this, I2 by I1 will be equal to, we will get like this, it will be equal to R2 by R4. Now when we will relate this equation 1 and 2, we will get one relation, that will be R1 by R3 is equal to R2 by R4. Or we can say like this here, R1 by R2 is equal to R3 by R4. Okay, or we can say like this, R1 into R4 is equal to R2 into R3. These three forms we can write for a KVL equation. You can see here, ratio of these two is equal to ratio of these two, or ratio of these two is equal to ratio of these two, or product of these two, diagonal product of these two is equal to product of these two. It is a condition for, balanced. Why we are saying balanced? Because to have I is equal to 0, we are balancing this part, we are balancing the left part and right part, balancing this part and this part. Okay, condition, what is condition for a balanced Wheatstone bridge? This. Okay, now R1 by R3, this form you should remember. Any problem? I have done in short, skip the derivation here. I have done here, you can see. Similarly, I have skipped here. Any problem in this condition of balance Wheatstone bridge? Any problem? Okay, this is very important. You will get lots of numerical to practice to this concept. Any problem in understanding Wheatstone bridge? Any problem in understanding balance Wheatstone bridge? Any problem? Okay.